All right, here's your first blank. What gases are in Earth's atmosphere? I have seen AP test questions on this, multiple choice, that say, which is the gas that makes up the largest percentage of our atmosphere? It is nitrogen. Okay, nitrogen, and nitrogen is in the form of N2. Remember we talked about nitrogen in the nitrogen cycle? We said N2 gets into the soil through those plant roots, the legumes, or through lightning, right? And it has to get converted into nitrates into the soil. Okay, so in your blank here, you're writing down nitrogen is 78%. Oxygen is 21%. What does that mean? It means all of the rest of these gases make up a tiny, tiny percentage, and that includes greenhouse gases. Are all these greenhouse gases? No, because they didn't put all the greenhouse gases in here because there's such a small percentage. So the big idea here is even though greenhouse gases don't make up a large percentage of our atmosphere, they're having a big impact, okay? So what exactly are our greenhouse gases then? What types of greenhouse gases are there that exist? The first one is water vapor. You might say, well, water is necessary for life. We need it, which is true. Okay, water vapor is the most common greenhouse gas, but we don't really care that much about it. The reason we don't care that much about it is because it absorbs, while it absorbs infrared radiation from Earth, it doesn't last very long. Because we know that water evaporates, or it forms clouds, it condenses, it forms precipitation. It doesn't last very long, and so we don't care about it. It's also not a significant man-made produced greenhouse gas. So even though water vapor can be produced from human actions, most of it is produced by natural processes. So we have water vapor, we have carbon dioxide. Okay, we have nitrous oxide. Now this is different than NOx. Remember, NOx is what comes out of smokestacks and cars. Okay, this is N2O, and N2O is different than NOx. Okay, so we've said nitrogen oxides or nitrogen dioxide. This is nitrous oxide. I know it's really confusing, but just know there's a difference there. Methane, where does methane come from? Landfills, termites, we'll talk about more. Ozone, okay, and then CFCs. CFCs are those chlorofluorocarbons found in refrigerants, air conditioners, aerosols. They're the things that destroy the ozone layer, all right? So if we look at this table, we have a table here. It talks about the greenhouse gases over here. Got water vapor, CO2, methane, nitrous oxide, CFCs. And then duration in the atmosphere. So water stays in the atmosphere for 9 days. CO2, years to hundreds of years. Methane is 12 years. Nitrous oxide, 114 years. And CFCs, 55 to 500 years. So which one lasts the longest? CFCs. Okay, so chlorofluorocarbons, the things that we have been creating. A lot of you got the question wrong about which type of legislation reduced CFCs, and that was the Montreal Protocol. That was on the multiple choice. So which lasts the shortest then? That would be water vapor. And then we're going to talk about something called warming potential. So which one is able to warm the most? Okay, and so we see water vapor is less than 1. Carbon dioxide's a 1. Okay, methane's at 25. So even though methane is not as common as carbon dioxide, it has 25 times the warming power as CO2. Nitrous oxide, 300, and then CFCs, 1,600 to 13,000. So the most warming potential, CFCs. And the reason this is because if you remember, with a CFC, it can destroy that ozone molecule. It's what we call a catalyst. It destroys the ozone molecule, but it itself does not get destroyed. It gets to be reused over and over and over. And that's why it's such a strong or potent greenhouse gas. So when we talk about greenhouse warming potential. This is what we're talking about. It's kind of a long definition. I'll let you write it down, and then I'll explain it in a sec. So it estimates how much a molecule of any compound can contribute to global warming over a period of 100 years relative to a molecule of CO2. Sometime when I'm bored, I'll try to figure out how to make this shorter, but I have no idea how to make this definition shorter at the moment. So it's always compared to carbon dioxide. And that's why, if you'll notice, CO2 is given a potential of 1 because that's our baseline. And so we compare everything else to carbon dioxide. So with methane, we give it a score of 21, meaning it is 21 times greater increase, it causes a 21 times greater increase in warming than a single molecule of CO2 because it can last longer and because it can trap more heat. Nitrous oxide is 310. HFCs, PFCs, and sulfur hexafluoride. These are all things that are created man-made, similar to CFCs, but HFCs and PFCs were made to create or to replace CFCs. And so some of these last 23,000, 9,000 years. All right. And so when we look at global warming potential, that can tell us how dangerous these gases are in our atmosphere. So CO2 is still the most abundant, right? And contributes most of our greenhouse effect. But when we talk about these other things, even though there's a really tiny amount of them in our atmosphere, they still contribute a lot to the warming. So what are our sources of greenhouse gases? We talked about volcanoes. So volcanoes cause cooling because the ash blocks the sunlight. Decomposition, decomposing. So CO2 is made when things decompose. But that's only if there's oxygen around. If there's no oxygen around, then we get those anaerobic conditions, like in wetlands or in the guts of animals, particularly cows and termites. They have little bacteria that help them decompose different things, and those bacteria produce methane. So decomposition creates CO2 and methane, 2 different greenhouse gases. We also have denitrification. This was something that we talked about a long, long time ago with the nitrogen cycle. So if you remember, nitrogen exists in the ground, okay, as NO3, nitrates, and that's what plants take it up as. But some organisms can return it to the atmosphere, and sometimes instead of returning as N2, it returns as N2O. Now, N2O is a greenhouse gas. When does this happen? Again, where we get these anaerobic conditions, really wet soils or wet lands. And then last but not least, we have evaporation and transpiration create water vapor, which we know is a greenhouse gas. So our last slide then is going to be anthropogenic sources of greenhouse gases. So what does anthropogenic mean? Man-made, okay? So instead of naturally occurring, we have man-made sources of greenhouse gases. And for man-made sources, first one we have here, burning fossil fuels. I'm just going to have you write produces coal. I don't know why I put the other stuff on there. Just write produces coal. So fossil fuels burn coal. All right, agricultural practices. This is the most you have to write here. So over irrigation. Irrigation is watering. So if we overwater, that causes there to be not a lot of oxygen in the soil. Well, there's not a lot of oxygen. That's when we get that anaerobic respiration. So we're going to get methane and nitrous oxide being produced. We know livestock produce methane. That's why you'll hear people talk about cow farts contributing to climate change. Okay, because cows produce methane in their gut. And so the more cows we have, or the more livestock we have, the more methane they're producing. And methane's a greenhouse gas. So some people have said, well, we need to stop eating so much meat, not only because it uses a lot of energy, but also because it creates that methane, which is that greenhouse gas. So deforestation releases CO2. You guys know that. Cutting down trees releases CO2. Landfills create methane. And then industry creates those CFCs, chlorofluorocarbons, and HFCs, which are detrimental to the ozone layer.